So today we're talking about after-treatment systems, and I have listed the emissions that we're trying to deal with for the after-treatment systems. The engines were producing emissions. They're supposed to produce water and CO, or carbon dioxide, so harmless, but they don't because of different conditions. So this was recognized in 1956 by the emission standards were being created because they realized what was coming out of the vehicles was not simply water and carbon dioxide, but we were getting carbon monoxide because of improper burn. We were getting particulate matter, again, improper burn. The fuel's not being burned, it's coming out as soot, black smoke, ash. Sulfur was in the diesel fuel, a lot of sulfur in gasoline back then. It was lead was the problem. And so one of the things they did in diesel engines is they made them higher compression, built the engine stronger, made them higher compression. Later on they added turbochargers, so up to 20-to-1 compression within that cylinder. So the heat was turned up. Putting a full shot of air into that cylinder every time, compressing it, adding fuel, the heat rose. And that raising that heat burnt off a lot of this particulate matter. And as long as the oxygen was getting into that engine, reduced the carbon dioxide considerably. However, filters get plugged, problems, timing is out, and we weren't getting enough oxygen, so carbon monoxide was being created as well, and particulate matter was, if it didn't burn down the pipe and come out, it came out as black smoke and was causing pollution. So this was being recognized in 1956, and in 1963, more for automotive, the Clean Air Act came out and said, this is a standard for vehicles, engines on the road, and we have to start cleaning this up. Government agencies were aware of the problems. They were aware this was coming out, and they formed a group called the Environmental Protection Agency. And this is a standard that can be used worldwide to make sure that the vehicles aren't putting out these pollutants, or a very reduced amount. And systematically, they've been reduced. In 2002 is when sweeping changes happened. This is what shocked the engine manufacturers, that they wanted to reduce the particulate matter and the NOx by 50%, which was a huge cut. Again, in 2007 and 2012, maybe 13, there was more sweeping changes that fundamentally shocked them. So we had these steps. We recognized there was a problem. Clean Air Act was formed saying, what can we do? EPA was formed in 1970, which started creating standards, so such as on automobiles, catalytic converters, air pumps, to clean up the air. And diesel engines were trailing behind, but they were being watched at this point. In 2002, EPA came out with changes that shocked the world, and they had to start changing the way they did things. Very soon after, EGR was introduced. Now, EGR had been on automotive vehicles since 1970, and what exhaust gas return does is it takes some of the exhaust gases and puts it back into the intake manifold. Therefore, there's not as much oxygen, there's not as much combustion, lowers the temperature in the combustion chamber, which was supposed to solve some of the NOx problems. However, on a diesel engine, the same thing happened, but the EGR had to be cooled. So the exhaust coming out from the turbo or the exhaust was sent through a cooler, cooled down, and then put back into the combustion chamber through the intake manifold. In a turbocharged vehicle, this could be a bit of a problem because the intake manifold pressures could be higher than the exhaust pressures. So they had to find a way to use this cool, fairly inert exhaust gas and put it back into the intake manifold to go into the combustion chamber. This would have two effects. It would cool down the combustion chamber because the exhaust is cooler, and it would not give as much oxygen, so such a burn. Controlling the amount of fuel going into that cylinder, reducing the oxygen level, cooled the engine down, and that would reduce NOx. The VGT, or VDT, variable geometry turbocharger, variable displacement turbocharger, literally would change its pitch on the vanes so it could raise the pressure of the exhaust or lower it depending on the situation of the vehicle. So computerization took over here. They had to use computers to manage this and be able to figure out when the VGT could cycle, either open or close, raising the pressure or lowering the pressure. we were quite aware that we could not use a VGT or a VGT, let's go with that, when we're driving up a hill looking for full power. So that was considered boost mode. And when the vehicle was in boost mode, it did make the particulates, it did make the NOx, but that was for the short time it was climbing a hill or really working hard. So the turbocharger would go into a position to make enough boost to get this engine going. Once it's up the hill and it starts cruising, the engine or the computer would send the engine into EGR mode, where it would create variable pressure depending on the VGT positioning of the vanes to control the exhaust pressure going into the intake manifold. So it used some sensors, and it would measure the intake manifold, it would measure the pressure of the exhaust, and the VGT would adjust itself so it would raise it high enough to get that exhaust gases into the intake manifold that could then go into the combustion chambers to lower NOx and particulate matter. So by lowering it during the straight stretches and when the engine wasn't under huge boost, it could control and reduce the amount of NOx coming out of the system. Now, one of the side effects of cooling, the reason we heated up the combustion chamber is because it reduced carbon monoxide and particulate matters. Cooling it back down to reduce the NOx had the same effect, and the carbon monoxide and the particulate matter levels went up. So they had to start thinking another way. Now, this didn't happen until after 2002. At this point, the EGR was managing the levels at 50% reduction in NOx and particulate matter. And then in 2007, new regulations came out. And these new regulations cut it by 80%, I believe, the particulate matter and the carbon monoxide. So the engine manufacturers had to go back to the drawing board and try to figure out, how do we take a turbocharged diesel engine with a variable displacement variable displacement turbocharger, or a variable geometry turbocharger that's working correctly, making the mandated changes at 50%, but now we're going to reduce those by 80% more. And so we're managing the NOx, but we've got carbon monoxide levels and we've got particulate levels that got to drop 80%. So they went back to the drawing board, and in 2012 they came out with an after-treatment system that would be added to the engines. I hope you found this helpful. I have another video coming up that's going to talk about the after-treatment systems.